Linear regression means mostly it describes about the relationship between the independent variable and dependent variable. If we want to build a linear regression model, it will assume there is some relationship between the independent variable and the dependent variable. For example, if we want to fit best linear regression line on the training data set with compared to dependent variable, it assumes there is some linearly positive or negative, whatever it may be. But there is some relationship between the independent variable to the dependent variable. We'll explain about the dependent variable. Dependent variable, in the name itself, it have the dependent. So it depends on other variables. So dependent variable is the target variable. That means what we are expecting. That is the output variable. Why we denoted it as a y. That is the dependent variable. For example, let's take the house price prediction case. Some client, he will provide some information about the houses and their prices. Whenever we get the new information, we need to predict what is the expectable price of that house based on the data what they provided previously. Okay, that is the case scenario. Here, what is the output? That is the price, prediction of the price. That is the output. We call it as a ground truth value or target value or output, whatever it may be. How do we predict this price? By depending on the house information, what they are provided, whether it is at which place it's located, how much square feet it's occupied, how many bedrooms it have, and what is the some other features that particular for example, which type of wood they used for the cupboards, like that, which type of interior they used, how they decorated their house. These are all the house information. By depending on this information, we'll predict the target or ground truth value, that is the price prediction. That's why we call it as a dependent variable. The house information, what we are providing input to the model, that is nothing but the independent variables. So independent variables is nothing but predictors. What we call means these are the predictors we used to predict the target value. Okay. Yes. Here, dependent variable, there is some other names for the dependent variable. Those are the target value or ground truth value. Just like that, we have the independent variables. We call it as a predictors or features, whatever it may be. But this is the difference between the dependent variable and independent variable or feature. That influence the depend. See here, the predictors is nothing but the independent variables that influence the dependent variable. So if is there any change in independent variable, that change will be impact on the dependent variable.
Correct.
Mostly we denoted as the dependent variable as y. We denoted as the independent variables x1, x2, x2. That means there might be only one dependent variable, but you can use any number of independent variable to build a model.
Okay.
These are the sometimes we will use frequently while building the model, while explaining the concept. That's it. Regression line. Regression line is the best fitting line that represents the relationship between the dependent and independent variables. I already told you linear regression model we build by assuming there is one assumption. Based on that assumption only we build linear regression model. That is nothing but the relationship between the independent variable and dependent variable. So we need to build one line to establish the relationship between the dependent variable, independent variable. Based on that line, whenever new point comes, we'll say this new point, based on this new point information, we'll say maybe this is the output for this new point. So to finding that relationship between the dependent variable, independent variable is the main thing while we doing the linear regression model. That is the best fitting line. That's what we call this type of linear regression model. That is the regression line. Okay, we'll say remaining things in this session in next slides. Coming to the residual, this is the another term we mostly used in the linear regression model. Let's say, for example, we have the house information. We have the based on house information, what is the price of that house? By using this information, we will build one model. That is the linear regression model. Whenever new house comes, we will provide this information as input to the linear regression model. Automatically, it gives the some price for that house. Is that price is exactly 100% what we are expecting? Is it predicts like that?
No.
Please remember, from the machine learning model or deep learning model, you can use any model. You can expect accuracy of the 99.99% till 99.99%, but it won't be 100%.
Okay.
Yeah. Why? Because just by analyzing data, we are saying there may be the house price of this house is maybe till from here to here. For example, whether it is 65 lakhs to 70 lakhs, whether it is 1 crore to 1.10 lakh, 1 crore 10 lakhs, like that. We are able to say it might be in between this range. But we can't say the price of this house is exactly 66 lakhs 6,000 like that. You can't estimate that exact. So, for example, the house price is actual price is the 67 lakhs, but our model predicts it is the 66 lakhs 50,000. Okay, whenever we provide house information, it predicts the 66 lakh 50,000. The what is the difference between the actual price and the predicted price? That is the 50,000.
50.
Yeah. What is that? That is the error our model predicts. The error our model gives to the price value. That is
Yes.
that type of error is nothing but we call as a residuals. The difference between the actual value and predicted values used to evaluate the model performance. Whenever after building model, we need to evaluate the what is the performance, whether it is working as expected or not. Based on these errors, for example, if the house price is 67 lakhs, if we predict 66,000 50,000, then it's not a problem. If the house price is 67 lakhs, if we predict whether it is the 70 or 71 lakhs or 61 or 62 lakhs, it may be it may be problem to the client whoever using our model. Okay. So based on this residual error, we'll evaluate our model performance. If the error is very less, that means our model is very good. If the error is very high, that means the model is not good. It won't give the expected values, at least near to expected value. If a residual errors are very high, means it won't give the at least it won't predict the value which is near to expected value, not exactly expected value, at least near to expected value. That's why that is the error. These are the some common terminologies we use, and these are the some patterns. Actually, I'm saying we are building linear regression model. We are building linear regression model. But on which basis we are building linear regression model? If we want to solve any mathematical problem, we need some equation, right? If we have the x value, y value, but if there is no relationship between the x and y, we can't predict, we can't calculate y value by the given x value. So if we want to calculate one value, we need to know about the other value, and at the same time, we need to know about the relationship between those two values. Then only we will calculate. So for the linear regression model, the mathematical expression is the y equal, you people already know mx plus c. That formula we used whenever while studying 10th or inter. Most of the people will use that formula y equal mx plus c. That is the
Yeah.
same thing here. Here the constant C is nothing but the beta naught mx, the coefficient of the x, that is the beta 1 x plus e. Whenever we predict model, there might be a slight difference between the actual value to the predicted value. That error is the this one.
Okay.
That error. So here y is the dependent variable, x is the independent variable. I already told you in previous load. Coming to the this beta naught, this is the constant term. We call it as a y-intercept. Y-intercept. And beta 1 is the coefficient. That is the slope of the independent variable. X is the independent variable. I already told you. E is the error term. This is the residual. So if we combine all these things, then only we will get the actual y value. Okay. In linear regression, coefficient represent the relationship between the impact of independent variable on the dependent variable. Here we have the x value, and if we want to calculate y value, what we do, we multiply my coefficient to the independent variable. If we provide x value one time, it won't be changed. Okay. But if we want to uh, calculate expected y value, how can we do that one? By changing the coefficient value. Is it? For example, y is the 8. Actual y value is the 8. But
Mm-hmm.
x value is the 2. If we provide coefficient, how we calculate that y value? Y equal to mx plus c. Here, let's consider constant term is the constant term beta naught is also 2. How do we get that y value? If we give the 2 for the coefficient, what will happen? Constant 2 plus 2 into x value is the 2. What will we get? 2 into 2 is the 4 plus 2, 6. But what is the actual y value? That is the
8.
8. If we want to get weight, shall we able to change x value 2 to 4? No. We
No.
can't change what client provides the information. We can't change the house square feet is the, it's not 1000 SFT. I want, if we want to predict correct model, we'll change this one to the 2000 SFT. They won't agree. How do we do? Surely we need to change our coefficient value. That is the beta 1 is, we need to change that 2 to 3. Then what will
Okay.
happen? 2 plus 3 into what is the independent variable? 2. So 3 2 is 6 and plus 2 8. This is the actually expected y value 8. So it's not possible to change independent variable values to predict the expected y value. So whenever if model is, if we want to perform model correctly, we need to give correct coefficients. So this coefficient is represent the relationship between the independent variable and the dependent variable. That's
Okay.
the importance of the coefficients.
Okay.
Coefficient determine the slope of the direction of the regression line. Slope of the direction means, for example, if we have taken coefficient value is the negative, what will happen? Whenever independent variable increases, automatically the dependent variable will be decreases.
Decreased.
Yes. If the independent variable decreases, automatically dependent variable increases. So
Increase.
the coefficient determines the slope. That is the direction. In which direction there might be the relationship between the independent variable and the dependent variable. So coefficient determines that type of information also. Quotient represent the change in the dependent variable for a 1 unit change in the corresponding independent variable. That's what I am saying from starting onwards. If is there any change in independent variable, automatically that change will impact on the dependent variable. How? By representing the coefficients value. For example, if one times of independent variable increases, coefficient times of dependent variable also impacts.
Yeah.
Yeah, why? Because we are multiplying our independent variable coefficient times. If coefficient is 1, 1 time. If coefficient is 2, 2 times. If coefficient is 0.5, half time. So, is there any change in independent variable? Coefficient times of change will impact on the dependent variable. For
Yes.
example, if the coefficient of an independent variable is 0.5, it means that 1 unit increase in the variable is associated with the 0.5 unit increase in the dependent variable. So based on the what is the coefficient value, that many times of unit is or that many times of increase in the dependent variable also affects.
Yes.
Yeah, this is the concept. We'll explain some more clearly. Let's see. What is the fit of the line given correlation coefficient? I already told you linear regression model assumes there is some linear relationship between the dependent variable and the independent variable. If there is perfect linear relationship between the independent variable dependent variable, then the linear but that this is the nothing but regression line will be looks like this. So all expected values and actual values will be same like this. Okay. If the
Yeah.
data points are not linearly correlated, those are non-linear correlation like this. If the data represents in non-linear, linear regression model won't fit for that data. We
Yes.
need to select other model for that data, whether it is logistic regression, whether it is SVM, decision tree, any other model. But linear regression won't fit for the non-linear data. So this is
Okay.
the another assumption for the linear regression model. See, coefficient can be positive or negative, indicating the direction of the relationship. This is the what I am saying previously, slope. Coefficient, if the coefficient is positive, there might be positive relationship between the dependent and independent variable. Whether it is negative, there is some relationship between the negative relationship between the independent
Dependent
variable
and
and the dependent. Yes.
dependent.
Yeah. If the coefficient is positive, what will happen? The dependent variable and independent variable are proportional to the each other. That means if is there any unit change in the independent variable in the increasing side, the
Yes.
same unit change will impact on the dependent variable in increasing side only. Why? Because both are have the positive relationship, so both will be proportional.
Yeah.
Whether independent variable increases, dependent variable also increases. Whether independent variable decreases, automatically dependent variable also decreases.
Decrease.
Yes. If there is a negative relationship between the independent and dependent variable, if independent variable increases, dependent variable will be decreases. If the
Okay.
independent variable decreases, non-proportional. That means the opposite direction. If one will increases, other will be decreases. If one will decrease, other will be increase. But there is some relation, whether it is positive or negative, it's not a matter. If there is a relation, we are able to build linear regression model. We are able to fit that best fit line, that is the regression line. Thus, the standardized coefficient, also known as beta coefficients, are obtained by the standardizing the variables. Standardizing means sometimes in data we will get the outliers.
Okay.
Outliers. Previously, I told you we have
Yes.
the Sai want to join into the yoga class or power workout class. For in power workout class, there is one guy who has the 90 years age. Due to
Yeah.
his mean will misleads him. So that type of outliers will present sometimes in the data. At that time, we need to standardize our data. That standardized coefficients also. For
Okay.
example, if we have that 2, 3 independent variables, what will happen if the one independent variable coefficient is very high and another independent variable coefficient is very less? What will happen? The independent variable always depends on the whose independent variable coefficient is very high.
Okay.
Okay, so we need to standardize our coefficient to build best regression line. They represent the standardized impact of the independent variables on the dependent variable. If we give the same coefficient values based on their relation, then each and every independent variable equally impact on the dependent variable. Why we are providing house information, what is the square feet, what is the location, what is the number of bedrooms, everything. So every parameter will be impact on the dependent variable. So we need to we need to give same priority for the all parameters, all which are have high relationship between the dependent variable. If is there any there is no relationship, we won't give any priority for them. But the parameters which have high relationship, we need to give same priority for the all those independent variables.
Okay.
So correlation coefficient. Actually, correlation coefficient R is the number between the -1 to 1. How do we measure the relationship between the dependent variable to independent variable? By calculating the correlation. It lies between the always -1 to 1. Why? Because if the correlation coefficient is -1, that is the relationship between both variables are very, very high, but the relationship is in negative direction. If the correlation coefficient is +1, there might be same high relationship between the dependent variable and the independent variable, but the direction is positive side. Both are good. So whether it is the positive linear correlation, it gives the best fit line. Whether it is the negative linear correlation, we are able to create best fit line. But if there is no relation between the independent variable or the dependent variable, that means there is no linearity on the data. So that is the nonlinear data. At that time, we won't fit best fit line on that data. So
Okay.
this correlation coefficient gives the strength and direction. Strength and direction means if it is 0.5 or -0.5, there is a 50% of relationship between the dependent variable, independent variable. That value 0.5 or 0.4, 0.6, 1 or -1, these are the strengths. Direction means if it have the positive side, that means the positive in both will uh, changes in same direction. Whether one is increases, other one also increases like that. If the correlation coefficient is in negative, that means there is a negative direction. For example, one increases, another will be decreases. So this correlation coefficient describes about the strength and the direction of between the two variables. Okay.
Ma'am, I have one question.
Okay.
Uh, Previously, when we have an equation for linear regression, then we can say that y is equal to mx plus c. This is the equation of line, right?
Yes.
So
Yes.
when we give the coefficient and we have the value of uh, any x or and let's say x, so we can create a line, right? We
Yes.
can
Yes.
create a line between x and y. We once we get the value of x, then we will get the value of y also.
Yes.
But in the correlation regression here in the previous slide, which you said, the value of r, where we will put the value of r so that we can get the line in the first graph. Is there an equation for it for means
No.
putting
For
the
ex
value of r?
Yeah. For example, what we are seeing, what we are observing into marks, these are the actual values and predicted values. If the point lies on the linear regression model, that means what is the actual value y have, same value our model also predicts. Then only all expected values are lies on the regression line. If we,
Okay,
how do we get this y value? Y equal beta naught plus beta 1 x1 plus error. Okay.
yeah,
That
yeah,
beta naught beta 1, that is the coefficient. By using only that coefficient, we predicted this value. For example, you consider this is the one predicted value. We, by using those coefficient and x value only, we are calculated this value.
correct.
Yes, we are calculated this value. This line, what is the line is the actual values, y actual values. What are the into points we placed on the line, that is the predicted value. How do we
Okay,
predict that value? By using these coefficients. And don't just this is the correlation coefficient, this is not actual coefficient. That is the beta naught,
Okay.
beta 1, what I said. That beta 1, beta not the same value, these values.
Okay.
These are, first, let's see, if we want to build linear regression model, we have the two assumptions. That is that there is some relationship between the independent variable and the dependent variable. That is the first assumption. Second one is that there is the linearity in the data. So if we want to build linear regression, first we need to know about these things. How do we know whether there is a relationship between the dependent variable or independent variable? How do we know? By using this correlation coefficient. First, by using this correlation coefficient, we'll check whether there is any relation between the dependent variable and the independent variable. If we observe any relation, then only we build linear regression on that model. If there is no relation, we'll go for the other model.
Okay.
So
Okay.
we need this type of visualization
Okay,
before
ma'am.
going to the model. Yeah.
Yeah.
Yeah. Coefficients play a crucial role in
Ma'am,
linear
R can
regression.
be any value, ma'am.
R can be any value, but it comes based on the relationship between the dependent variable and the independent variable.
Independent.
Yeah, yeah.
When there will be no
Don't worry. We
correlation.
have in Python we have the libraries to calculate the correlation between the dependent variable and the independent variable. If we provide dependent variable, independent variable both to that library, automatically it gives the value whether it is 0.4 minus 0.4 or 0.8 based on the relationship between the two variables.
Okay.
Okay, ma'am.
Yeah.
And if there will be no correlation, then we have to go for
It
another model.
Yes, yes.
Okay.
For example, if we have the 30 different independent variables, out of the 30, we have the 20 variables, 20 independent variables have the relationship between the dependent variable. Other 10 does not have any relation. What we do? We'll do whoever have the relationship between the dependent variable will select that features to build a model. That depends on the data, depends on the what we are expecting, everything. We won't go if there is no relationship between the one independent variable to the dependent variable. There might be some other variables which have the high relationship between the dependent variable. What we do, we'll simply drop those variables which are doesn't have any relationship. We'll go through these models, these features also.
Okay.
Yeah, there might be that type of the help of quantity, the impact of the predictors. Predictors is nothing but the features or independent variables and aid in understanding the factors influencing the dependent variable. Thus, so the quantify means the predictors based on the predictor values. Actually, I'm saying about the coefficient. How do we calculate? How do we get that coefficient value? So whenever we while training data by using the linear regression or to build a linear regression model, it will calculate the by randomly it takes the some coefficient value. It will try to predict y value. If it is the expected y value, then it will use same coefficients for the other records. If we have the 10,000 records, first it will take some value, coefficient value for the first record. If it is expected value, it uses the same coefficient for the second record also. If is there any difference, so based on that difference, it will change its coefficient value. Okay, like that it will do. Don't worry. We'll explain everything in Python also. How do we calculate it? Yes, this one. So till now, we have the data. We know the how to select features based on the relationship. Then after we build the model. What we need to check model performance. We need to check model how it's working. Okay. That is the two. There is the two measurements. That is the R squared and the mean squared error. R square means it is a statistical measure indicating the proportion of the variance in the dependent variable explained by the independent variable. That means we already know there is some relationship between the dependent variable and the independent variable. This R square measures the how much variation in the dependent variable explained by this independent variable. There is some relationship, but by using that relationship, how much of y value we are able to predict by using this dependent variable. So based on that, if R square, based on this information, for example, let's take there might be very high R square value. That means this independent variable explain about the lot of information about the dependent variable. If the R square value is very less, that means these independent variables doesn't have that much information about the dependent variable.
Okay.
Yeah. If the model is very good, that means automatically the relationship between the independent and dependent is also very high. That means R square value will also very high.
Fine.
Yes, like that. Coming to the mean squared error means the average of the squared difference between the actual and predicted values. That what I said previously. For example, the cost of the house is 67 lakhs, but our model predicts it as the 66 lakh 50,000. What is the difference between the actual and different? That is the value. So that how do we take that one? First, for example, we predicted 10 house prices. So we will take the mean of those 10 house prices. We'll calculate the what we do. We already have the 10 houses actual prices also. What we'll do. So we need to calculate mean squared error means we'll take the sigma of x minus yi by n. Y means here predicted value. Y actual minus y predicted value. So we'll take the sum of squares. Why? Because there might be some chance for sometimes plus minus. For example, let's take if we are calculating errors one time instead of 67,000, it predicts as the 66,000, 50,000. For the some other house, instead of 67,000, it predicts as the 67,000, 50,000. If we try to get how much error we are getting on all the houses, if we are summing that one, what will happen? Previously, it might be minus 50,000. In the next houses, it gives the plus 50,000. What will happen? These two will cancel. So it says the error is 0. So to avoiding that problems, here we are calculating the mean squared error. Mean squared error means we won't consider magnitude, whether it is a positive or negative. Just we are consider the error of that particular value. So like that, it will calculate the error of the linear regression model. If the error is very high, our model is not good. If the error is very low, that means our model is good. So these are the two parameters we used to evaluate the model. Let's take R squared. It's a statistical measure used to access the goodness of the fit. It indicates the proportion of the total variation in the independent variable. So if we are able to find what is the variation in the dependent variable by using the independent variable, whenever new input point comes, by using this independent variable, we are able to predict expected output value, expected dependent value. If the variation in the dependent variable not explained by the independent variable, whenever new point comes, it predicts the garbage value, not as expected value. So that's why this R squared value proportional to the variation of the dependent variable is explained by the independent variable. That's all. How much is the 90% variation means there might be chance to give predictions 90% accurately, like that. R here I am saying R square. Why? Because we are instead of doing R value, we'll take the squared values. Why? Because sometimes there might be chance. It is the negative error, maybe positive error. If we did not apply square on that, this negative positive error will be cancelled. It will say there is no error in the model. So there is a chance to mislead like that. That's why we are using measurements and the squared values. So it always ranges between the 0 to 1. If the R squared value is 0, that means independent variable doesn't have any information about the dependent variable. If the R squared value is 1, that means independent variable have the all variation about the, that means total variation about the dependent variable. That's what. If the R squared means 0 means there is no relation. There is sometimes, uh, there is some relation between the independent variable and the dependent variable, whether if the independent variable increases but dependent variable also increases, but the relation between both is not make sense. It won't be any sense. Sometimes it will happen. So we need to this R squared value, if we calculate the correlation coefficient, it gives there is lot of relationship between the independent variable and the dependent variable. But this independent variable have the relation, but this relation won't explain about the variation in the dependent variable. So at that time, our model fails. How do we find that failure? By using the R squared value. If the R squared
Okay.
0 means that none of variation in the dependent variable explained by the independent variable. If the R square value is 1, that means the a total variation in the dependent variable explained by the dependent variable.
Okay.
Yeah. Let's see. Till now, I say correlation coefficient, correlation coefficient, correlation coefficient. So how do we calculate that correlation? How do we calculate R square value? R square value we are getting from the correlation. That is the S square. Actually, SXY is the R value. We are always thinking about the R square. That's why X minus X naught. That means for example, let's take here interest rate is the independent variable. Future index is the dependent variable. Interest rate is the independent variable. Future index is the dependent variable. So this is the X, this is the Y. How do we calculate relationship between these two? First, we'll calculate the mean of independent variables. Then after, we'll take the difference between the each point to the mean value. Here X bar means the X mean value. Mean is nothing but the average value. Y bar is the Y mean value. So by subtracting each point in the independent variable from the mean value, just like the each point in the dependent variable to the dependent variable mean by n minus 1. N means how many data points we have. Here we have the 12 data points. 12 minus 1. We will get the s square xy by xy. Sxxy. How this is the formula we used to find the relationship, that is the correlation or covariance. Okay.
Okay. So interest rate is the independent value that is,
X
no,
value.
sorry, okay.
Interest
So
rate
it
is the
is,
independent variable, that is the X values. Yeah.
okay.
Future index
Uh,
is the dependent variable what we are
that,
expecting as a output.
okay. That is why.
Okay.
Okay.
Yes, yes. Let's take here I calculated the mean value. This is the independent variable mean value. This is the dependent variable mean value. These are the difference between the X and average of the X values, like this.
Okay.
And
Then
X
after
naught means mean value, ma'am.
yes, X bar means mean value. That is the average value. This one, 7.74.
Okay.
Y bar means that Y value, 227.08.
Okay, ma'am.
Yeah. This and then after I calculated the product, I sum. Here what I gave the sigma. Sigma means sum of the each values. So that is the 12.216. 12.216 by how many points does we have here? N minus 1. Total we have the 12. 12 minus 1 is the 11. That is the
11.
1.111. So if we want to here R is the S square xy by sy. S square xy. So here we have the x and y. That's why we calculated for the xy. For Sx, Sy, Sx and Sy. This is the Sx, x minus x bar by n minus 1. Sy means y minus y bar by n minus 1. So if we do that one standard deviation, that is the 0.22, 6.07. If we apply, we'll get the R squared value is the 0.65. That means independent variable will explain 66% of the dependent variable variation. R square value is here, R square value is the 0.66. That means 66% of variation in the dependent variable explained by the independent variable. Okay.
Okay.
Ma'am, how can we get the SX and SY values, ma'am?
Yeah, same. See, s square x y, we calculated x minus x bar, y minus y bar. If we want to calculate sx only, sx, what we'll do? X minus x bar by n minus 1.
Okay, ma'am.
S square x is equal sigma of x minus x bar by n minus 1. We want Sx. What we'll do? We'll send this square value to this side. What will happen? Sx is equal square root of sigma x minus
Sigma
x
X
bar
minus
by
X.
n minus 1. Same
Okay.
formula apply for the Sy. Sy is equal square root of sigma y minus y bar by n minus 1.
Okay.
That is the standard deviation. That is the variation in this data.
Okay.
For example, that's what I said. If we have the R squared value 75, that means 75% of the variation in the dependent variable is explained by the independent variable. The remaining 25% variation in the dependent variable not explained by the independent variable.
Okay. Here, ma'am, the explained means what the expression it is telling about. What is the context of using explained?
Explained means, for example, let's take the same take house data set. If we have the house location data information, how much square feet it occupies, and whether it is
Okay.
gated communication or not, how many bedrooms does it have, which type of interior they are using. So if they
Okay.
will provide this information, so by
Okay.
using this information, shall we able to say exactly 100%? There might be a chance of this much of amount, this much of price may be applicable for this house. What we are
Yeah.
able to do based on this information, there might be a chance, it might be some price value, there is a chance for the 80% or 90%.
Correct.
We can't say
Correct.
the 100% about the that.
Yeah.
So if the values of location are what is the information I said, square feet, interior, everything, if it
Yeah.
changes, automatically price will changes, but every time it will say 80% only. It won't say 100% based on this
100%.
information.
Okay.
That is the
So,
relation. 75% means by using this input data, we might be predict our output data 75% accurately. Not we
okay.
can't say this is the 100%. It might be definitely this is the price.
Okay. Okay. Here,
Yeah.
in the sense, 20 for the 25%, we do not have any explanation
Yeah.
why the price has been increased or what is the
Yes.
why the variation has taken
Yes.
place.
Yes. If
Okay.
you, for example, let's say if you can take stock market, it will go ups and downs every week. 1 week up, 1 week down, 1 week up, 1 week down. There might be suddenly it increases very drastically.
Okay.
But in past data, we don't have that information. Due
Yeah.
to that, our model will say there might be some increase, but it won't able to say there might be drastically increase. There might be a chance to increase it drastically. Why? Because it doesn't. The past data doesn't have that information.
Yes.
Yes. That's what, if 75% information we have, so based on that information we'll say. If there might be any sudden changes, we can't explain. That's what. If
Okay.
we provide some more information about the dependent variable, maybe this explanation will be increases to the 75% to 85 or 90 also.
Okay.
Yeah, if we are providing more information about the dependent variable, then we will get not only that one. In as a human being, if we know some subject about the while learning lot, we will get the high knowledge about that subject.
Okay.
Like that,
Oh,
how much input we are providing to the model, based on that much accurately we are able to predict our actual value, truth value or ground truth value.
okay, ma'am. In just a normal question that means as we have 75% of variation and we do not know about the 25%, right? So in the actual in real scenario, in the business scenario, when this type of scenario comes, then how the business goes means business always say that okay, no, I want only I want above 85% or above 90% the explained data, and 15% is unexplained, then it will be fine, then we can go ahead and take this decision.
Yeah.
Or how
Whenever
much?
we get this discussion in the real time scenario, there might
Yeah.
be two chances. One thing, we'll ask them the some more data, which is have the high information about the dependent variable. If they have data, they will provide. So by increasing that data, we'll try to improve our model. We have the some other techniques also, PCA, regularization. These are the some techniques to improve our model accuracy. If after applying all methods, but still we are not able to achieve more than 80%, but the client expecting 90%, what we'll do at that time, will at least we are trying to change the data, or we are trying to increase the data. If the client will provide the data, that's okay. We will
Mhm.
increase our model. If the client doesn't have information, what we'll do? We need to scratch data from the web, or we need sometimes we need to provide or we need to prepare data ourselves.
Okay.
Yeah. So if we have the some data, it's not that much typical to prepare some more data.
Okay,
For
okay.
example, let's take the cat and the dog scenario. They give the image classification problem. So whether it is the cat or dog, they have the only 1,000 images related to the cat, 1,000 images related to the dog. By using those images, we created one model. It gives only 50% accuracy, but client is expecting 90% accuracy. He doesn't have
Mhm.
any images more than 1,000. What we will do, by flipping, by rotating those images, we will create some more images by using one image. For example, let's say if we have the one image, if we rotated it 25%, 30%, 50%, 60%, 75% like this, or by flipping up and down, by flipping right and left, we
Okay.
are able to create by using one image to 10 images. What will happen? These 1,000 images will become 10,000 images. So for the cat, it is the 10,000. For the dog, it is the 10,000. Previously, we have the only 2,000 images. That's why we are
Mhm.
getting only 50% accuracy. Now we have the 20,000 images. So there might be chance to improve our model accuracy 50 to 75%.
Okay.
Yeah. So like this, there are while building models, we will get those ideas.
Okay.
Yeah.
As
How
the
do yes.
as the collection of the data increases, the accuracy also means may have the chances to increase.
The collection of good data.
Okay. Okay.
Yeah. If for
Collection of,
example, we collected the garbage data. For
yeah.
example, if we want to classify dog and cat, we need only dog and cat images. If we provide other animals images, it won't. For
Yeah.
example, if we have the data set 100 images, we have the 70 images which are related to the cat and dog. It, cat and dog images are very high compared to other 30. But if we provide due to because of these 30 images, the model will confuse while predicting whether it is the cat and dog.
Yes.
Before
So
we build a model, we need to clean our data. That is also very important. If is there
okay.
any outliers, if is there any unwanted data, if is there any data which is misleading our predictions, misleading our information, we need to identify that type of data. We need to avoid that type of data.
Okay. Okay. Okay.
Yeah. Not only every time if we increases a model will give good accuracy, good accuracy. Sometimes if we increases due to increasing of this type of garbage data, our model accuracy will become decreases.
Okay.
Yeah. So we
So
need to aware about the data before build a model.
okay. 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 Got it.
R squared does not indicate the causal relationship between the variables, only strength and the relationship. Actually, it says about the strength, but for example, see, it does not reveal whether the relationship is meaningful or significant in practical terms. We are saying the 75% relationship between the dependent variable and the independent variable, but whether it is meaningful or not, it won't say that one. That's what if we have the relationship between the, for example, some animals, other animals also looks like say dog, some other animals looks like say cat. Also, based on those features, if this R squared value says, yeah, there is some relation between the input output, that is the 80%. But how it is, whether it is meaningful or not, it won't be explained. So this R squared can misleading when dealing with the complex models. For the simple model, it's okay. Whenever complex model comes, at that time, there is a chance to mislead us this R squared value. These are the some limitations with the R squared value. To
Okay.
avoid that limitations, we'll use adjusted R square value. This adjusted R square value, how it comes, it's based on the predictors or independent variables. It takes into account the number of predictors in the model penalizes our the inclusion. For example, what if we have that lot of independent variables. Out of the, for example, let's take the 30. Out of the 30 independent variables, 30 have the relationship between the dependent variable. But out of the 30, 10 only have the meaningful relationship between the these independent variable to the dependent variable. Other 10 variables which are have the relationship between relationship to the dependent variable, but it's not that much meaningful. What will this adjusted R square will do? It reduces the or it will ignore those 10 variables which doesn't have the meaningful relationship to the dependent variable. Okay, it provides more reliable measure of the model's goodness of it when comparing models with different number of predictors. If we have the lot of number of predictors, then at that time this adjusted R square value gives the reliable measurements. R squared is useful metric for the understanding the proportion of the variation in the dependent variable explained by the independent variable. So limitation should be interrupted or in conjunction other evaluation measures. So due to this drawback, we sometimes will go for the other measurements to evaluate the model. For example, let's take the mean squared error. Mean squared error is the metric used to evaluate the performance of the regression models. Mostly for the regression models only we'll use this MSE value. Why? Because regression value means its output is continuous variable. Continuously, you people already know which measurement is the measurable. For example, house price prediction. It might be 10,000 to 20,000 or 10,000 to some crores. But coming to the discrete values, it is the countable, whether it is 5, 6, 7, 8, 9, 10, whether it might be 30 or 40. That is the discrete value. That means categorical. Sorry, some categorical, not to the discrete value, coming to the categorical. If the output is a numerical value, we'll use for the regression models. If the output is categorical, we'll go for the classification model. Sorry, I
Ma'am,
missed to say this one in start of the event. There are we have the two types of data. One is the numerical data, another one is the categorical data.
okay.
Yeah. If the output Y is the numerical data, for example, house price prediction, salary prediction, or some other house price, some other voting poll predictions, everything, it comes under the regression model.
Numeric.
Yes. For example, there is some categorical output. That is for example, whether it is a spam or not, whether the mail is spam or not, whether this one or that one. That is the categorical. Spam or non-spam, it's the numerical data. There is same importance between this spam and non-spam.
Okay.
Whether the cat and dog, to classification of the subjects. If we have a lot of files, we need to classify whether it is math, physics, chemistry, some languages, anything. There is the same difference for the maths, physics, chemistry, Hindi, everything. So that is the categorical data. If the output is categorical data, what we are expecting output, then we'll go for the classification model.
Okay.
Yeah. So MSC means for the classification model, for example, let's say we have the spam and non-spam. Whether the output is 1, that is the spam. Whether the output is 0, that is the non-spam. How do we calculate? We'll take 0.5 as the threshold value. If the predicted value is 0.6 or 0.7, we'll directly assign 1 to that 1. It is the spam. If the predicted value is the 0.4, 0.3, what we'll say? We'll directly this is the non-spam.
Non-spam.
So we are saying directly whether it is the spam or non-spam. That is the actual value. So we can't, if we in the house price, it is the 67 lakhs, but we are saying 66 lakhs. So there is some difference. But here we are clearly saying whether it is the spam or non-spam. So there is no error. That error means it is the spam. We are saying non-spam. That means complete opposite. 100% wrong. That is there might be error, just some difference. But here completely wrong. 100% wrong. So this mean squared error measurement will applicable for the regression models, whether it is the linear regression, logistic regression, any other regression models. For the classification model, we'll go for the other measurements. We'll say at the time.
Okay.
Okay. So that's it measures the average of the squared differences between the predicted value and actual values of the dependent variable. How do we calculate that one? For example, MSC equal 1 by n. 1 by n means if we are using 30 records for the testing purpose, that 30 number is the number of data points we are using for the test, that is the n. Why I? That is the actual value. Already we know that. How do we, if we want to test something, we need to the first what is this actual value. Then only whenever they say whether it is that we are predicting this is the 1230, then we'll compare both. Based on that information, we'll say whether it is working or not. So for testing purpose, we need to available with the actual values. So actual value minus predicted value whole square. I already told you so many times why we are using square instead of positive or negative values. To avoiding that type of positive negative, we are using these squared values. So sigma of y actual minus predicted value square by n. Here yi is the actual value of the dependent variable. Y bar is the mean of the actual values, and n is the observations. Number of observation. How many data points we are using to test the model. Okay.
Okay.
So MSA is always non-negative. Why? Because this is the squared value. With
Well,
lower values indicating the better fit, that means if it gives the lower value, that means lower error. That's why that is the better fit. It quantifies the average magnitude of the errors made by the model in predicting dependent variable. So it says the particular, for example, if we measuring error between the 0 to 1, it says whether it is the 0, that is means no error. Whether it is the 1, it completely fails. Whether it is 0.2 or 0.0202, this much of error presented in the dependent variable. So it will say that quantity also, how much quantity of error that model provides. Whenever new input, we provide it to the model. Squaring of errors gives more weight to the large deviation from the actual values. Weight or large deviation from the actual values. So uh, that's what I'm saying. If we did not provide any squares, what will happen? If based on the positive negative values, it will become very small error. Whether there is some error placed in the model, but it says that there is no error. It is very very less. By squaring only, we are able to identify the exact error, that is larger deviation from the actual values. Comparing MSC value. What is this MSC value? Whether it is useful for only to identify error or other purpose. MSC can be used to compare the performance of the different models. For example, we build it by using the linear regression, logistic regression, super vector mission regression. How do we know which regression model is better to compare to others? By using this MSC. Which model have the less error, then we select that model is the good model. Okay. To comparing other models also, this MSC value will be useful. If model with lower MSC considered to have better fit and high predictive accuracy. That's the matter. If the error is very low, that means it gives the good accuracy. If error is very high, accuracy will be reduces. MSC should be interpreted alongside other evaluation metrics to access the model comprehensively. So that's what I said in first one and this one also. It is a metric to evaluate the model whether it is working perfectly or not. For example, first we build one model. It gives the high measurement. After increasing some dependent variable, after increasing some data points, maybe how this metric MSC will be useful, how the model is. If the by increasing independent variables and other data points, if the MSC will decreases, that means for which data points our model behaves as a good model, we are able to uh, compare that type of information. Previously, I said it will useful to compare 2-3 models. It is useful to compare which data set is you gives good model. In both ways, it will be useful. Okay. Do you have any doubts here?
Ma'am, I have
How?
a doubt in this. The point that is third point, that is squaring the errors give more weight to larger deviations from actual values. Means if we square the errors, it will deviate from actual value. Is it like that? Or, means,
Yeah. Yeah, yeah. For example, let's
okay.
see here y actual value minus predicted value, that is the 50,000. Let's take whether it is the 5. Let's assume that 5. If by squaring that, what will it happen? It will become 25.
Yeah.
Yeah. What we assume, oh my God, due to this, actually 5 is, that is the very low error. If we
Okay.
consider instead of using 5, if we are doing 5 square, that is the 25. So it is the larger deviation for the actual value. For example, what we are expecting, the expected value is the 50. it gives the 45. What will happen? There is the error between the 50 to 45, that is the 5 only.
Yeah.
By squaring this one, what will it happen? 5 becomes as a 25.
25. Yeah.
Let's assume if the actual value, say there is a difference between the actual value to the predict value is the 25. We are expecting 50, but it gives the 25. If we assume like that, what will happen? So that's what here he is saying. Squaring the errors gives more weight to the larger deviation for the actual values. So this is the drawback. How do we eliminate the drawback? We'll say here. Okay.
Okay.
Just to avoiding positive negative, we are doing the squares. Due to that
Okay.
square, what will happen? It's large deviation to the actual value. Actually,
Okay.
there is the deviation between the predicted value, actual value is the number 5 only. But by squaring like this, it will become 25. So uh, that's what here I want to say in limitations. MSE can sensitive to the outliers if their square difference contribute disproportionality to the overall value. Due to this square difference, whenever for the 50 to 45, it is that gives the 25. If we have the some outlier 90, previously in the
Mm-hmm.
score power workout station 13, 17, 19, then after 90, 90. Based on 13, 17, 19, what will it will predicts? It predicts as a 20 or 23 or 13, 16 like this. But the difference between these 20 to 90, what is the difference? 70.
Yeah.
So if we squared that one, it will become 4900.
Yes.
So due to that outlier, it gives the very high mean square error. But actually
Okay.
it predicts correctly for the 10 points. Due to incorrect, that is there is one outlier presence. Due to that, it it gives the very high mean square error. So due to this type of outliers, these squared values will affect it. It does not provide insight into the direction or magnitude of the errors individually. For the each point, it won't say the error. It will combine all errors. So to avoiding that, after squaring, what we'll do to avoid that square, we'll do the root square.
Okay.
Yeah. If we square, it will become x square. Then after, if we do root square, that root square and square will become cancel.
X.
We will get
Mm.
exactly what is
X.
the x value.
Yeah.
Yeah. That's why to avoid these limitations in the MSE, people will use root mean square errors. That is the
Okay.
root mean square error is the square root of the
MSc.
MSE value
Yes.
and has the same unit as the dependent variable. So now we will get the actual error.
Okay.
So it
Got
is
it.
often preferred as it provides a more interpretable measure of the average error magnitude. So this root mean squared error gives the exact what we are expecting, in which way we want to measure error. In that way, it will provides the more interpretable measurement, the average of the magnitude. Here till now, I am saying error. I am explaining in the words. Here will show invisible. For example, for example, let's say this point, this point, this point, this point. These are the actual outputs we have to compare the model predictions. But model predicts for instead of this x value, model predicts this as the point. In, Instead of this value, it predicts as this one. So it predicts like this. Here, the difference between this actual value to this predicted value, that is the difference. That is the
Okay.
error. We called the difference between this actual value to this predicted value. That is the difference. So our model predicts the y variable like this. If there is the linear relationship between points will goes like this, so there might be a very less error. If the points lies in this way, here, if we put a linear regression model like this, what will happen? The data points which are lies here only get less error. The points which are lies here, it gives a lot of error for those data points. That's why the main assumption in the linear regression model is the data have some linear relationship between the dependent variable and the independent variable. So it's same way, same thing, y equal to mx plus a, that is the formula for the linear regression model. A plus bx. A is the constant, b is the quotient. Okay. So
Yes.
we would do that by minimizing. Actually, this is the difference between the here yi is the actual value, y cap is the predicted value, that is the estimated value. So we need to minimize this error. This is the error. We need to minimize this error. Is also known as the residual. What we call the errors? Errors is nothing but residuals.
Residuals.
In data science terminology, we use the residuals as the terminology to say as a error. Yes, yes, yes. Okay. Is it? Do you want to? Do you have any other questions?
No, ma'am.
Yeah. MSE is the widely used metric to access the performance of the linear regression model. I already told you, if we want to actually classification, it will automatically say whether if the value is 0.5, 0.9, it automatically say it is the 1. If the value is 0.4, 0.23, it automatically say it as the 0 value. So we can't measure errors like this. If it predicts instead of 1, it is the 0, that is the complete error. So this MSC will be useful for to evaluate the performance of the linear regression models. It measures the average square difference between the predicted and actual values. These are some key points just for remember. So there are some limitations in the MSC due to this square. That's why we are using root square MSC value, mean squared error, offer more interpretable version of the MSC. Yes. So it is important to consider mean square error alongside other evaluation measures. If we want to compare other models, this will be useful. So of the models performance, if we have the lot of models to compare those models also, this MSC will be useful. Linear regression is a powerful tool for understanding the predicting relationships between the variables. Why? Because linear regression main assumption is that one there is some linear relationship between the two variables. If there is some relationship between the two variables, this linear regression then only useful to understand which type of relation they both have. The both variables will have. And it automatically provides whether the relationship in positive direction or negative direction. If it's the positive direction, is it completely positive with the 100% or 90% or 70%, like that also. If the 0, there is no relation. If the value is the 0.78, that means 80% magnitude. So it will say the direction, positive or negative. It says the magnitude also, how much relationship they both have.
Okay.
Yeah, mostly the main important thing, it assumes linearity and may not suitable for the complex relationships. If the data have the linearity, then only our linear regression model will be works. Okay. Till now, do you people have any doubts?
Uh, no, ma'am.
Uh, uh, sorry, Lakshmi. Lot of noise from your side. That's why I'm not.
So I don't have it.
Uh, okay. You people have any idea about the Python language? Lakshmi or Akash Kumar?
Uh,
Yes, ma'am.
Yeah. Don't worry. We'll provide one link for the to know about the basics of Python.
okay.